Problem 1, here you're given a pair of box and whisker plots. It looks like you have two bookstores and their prices. And for each bookstore, you have to first find the lowest price. So that's going to correspond to the minimum values. And with statistics, some sacrifice precision and overall accuracy for the big picture. Here, it looks like for bookstore A, the top box and whisker plot, the lowest price is about 75. Now, could it be 74 or 76? Yeah, it could. But an overall big picture sometimes is more valuable than, I don't want to say insignificant details, but smaller details. Here for bookstore B, the lowest price looks like is going to be 60. As far as the highest prices, looks like bookstore A is about 110, and bookstore B is a little over 120. So maybe 120, 121. Either or would be accepted on a test or a quiz. For the range of prices, remember the range is always the maximum minus the minimum. So for bookstore A, it looks like you have a maximum of 110, a minimum of about 75. So here the range of prices is going to be 35. For bookstore B, you have your max, and it looks like it's just past 120, so I'll go with 121. Here your minimum is going to be 60, so it looks like your range is going to be 61. So the range is always the max minus the min. The lower quartile refers to the start of the box portion of the box and whisker. So for bookstore A, I'm going to go with 78. For bookstore B, looks like it's going to be about 72. So those are the lower quartiles. And if this was a test, anything in that ballpark would be accepted. If you give the lower quartile to be 62 when it's closer to 72, that wouldn't be correct. The medians are the middle lines of the box. So it looks like for bookstore A, you're dealing with 95 or 96. For bookstore B, it's a smidge under 90, so maybe we'll go with 89. And the upper quartile is the right-hand ending point of the box. For bookstore A, I'm going to go with 105, and bookstore B, I'm going to go with, it looks like 110, 111 for the upper quartile. And now we get to letter G. You have to find the percent of books sold at less than $110. So here's going to be my $110 mark. Now, the advantage of a box and whisker plot is that it breaks the data up into quarters. 25% of the data is between the smallest value and the lower quartile. 25% of the data is in between the lower quartile and the median. 25% of the data is in between the median and the upper quartile, and 25% of the data is in between the upper quartile and the max. Just because this section for bookstore A looks smaller than this section for bookstore A, it's just the way the data turned out. It looks like for bookstore A, for example, 25% of the books are in between about $75 and $77. It just turned out that 25% of the books from bookstore A are in between, it looks like $78 and $95. But just remember, for box and whisker plots, the data is broken up into quarters. So for bookstore A, the percent of books sold at less than 110, I'm going to say is 100%. Why? Because 110 is the maximum value, and that means all of these books represent the entire data set. For bookstore B, 25% of the data is in between the upper quartile and the max, which means this section has to be 75% of the data. So the advantage of a box and whisker plot is that it breaks the data up into quarters. For letter H, which bookstore has a greater variety of prices? All you're looking for is the greater range. The variety represents the range of the data, and it's clear that bookstore B has the greater range. Why? Because the whiskers extend further to the left and to the right. Now, as far as letter I goes, which bookstore would you rather shop at and why? You can give a multiple of answers as long as they are statistically correct. For example, you can make the argument for bookstore B because, just what we answered in letter H, it has a greater variety of prices. It has a greater range. Again, the key is going to be for you to use statistics to answer your question accurately. You could say you might want to shop at bookstore A because bookstore A, all the books are under $110, while bookstore B has a quarter of their books more than $110. So whichever bookstore that you choose, remember in statistics, you can make data say whatever you want them to say as long as you back up your response with a mathematical fact based on your diagram. For problem 4, here you're given a side-by-side or a back-to-back stem and leaf plot dealing with the life of batteries in hours. And here the key tells you this. If you have a stem of 1 in the middle and a 9 to its left, like for example this 9 here, that means that battery A has a 19-hour life. If you have a 1 as your stem and a leaf of 5 to the right, for example, one of those leaves right there, that means battery B has a 15-hour life. So here for each brand, we need to find the minimum and the maximum number of hours. Well, if I just deal with brand A, the minimum would correspond to that 5. With the stem of 0, that would mean the number 05, or just 5 hours. And the maximum, it looks like the stem of 6 with this leaf of 1, would be 61 hours. So that's to the left, brand A. To the right, brand B, it looks like this leaf of 0 with this leaf of 7 with the stem of 0 corresponds to 07, or just 7 hours, so that's the minimum. And then the maximum would be this 5 with a stem of 7, or 75 hours. So using this side-by-side stem and leaf diagram, you're able to see the minimums and the maximums rather easily. Letter B, for each brand, find the median and the mode for the number of hours. Well, let's go to brand A and let's deal with the mode first. Here it looks like the most leaves I see together with the same stem are 2. So the stem is 2, the leaves are 2, so it looks like the mode of 22 for brand A. While for brand B, it also looks like there's 3 of the same, but in this case it's the number 5 with a stem of 1, so in this case the mode would be 15 hours. As far as the median goes, that's a little more involved. Here I'm going to count the total number of data. First we'll deal with brand A. So it looks like here we have 4 leaves with a stem of 0, 5 leaves with a stem of 1. Looks like I have 4 with stem of 2, I have 5 with a stem of 3, and then a 1 for a stem of 6. So here is my total number of data. If I add those up, it looks like there are 19. So the way you find the median is you take the total number of numbers divided by 2, and in this case, here since you have an odd number of numbers, you're going to round up. So here I'm going to get 10. So that means the 10th number starting from the bottom. So if I count from the bottom, the 5 would be the first. Then I have 7, 8, so I'm up to 4, 5, 6, 7, 8, 9. So it looks like the 10 would be this leaf of 1 with the stem of 2, so 21. Five, the largest number, 61, cross those off. The next smallest is 7, the next largest is 38, cross those off. The next lowest is 8, then 36, then the 8, and then the 34. If you keep doing this, if you do the lowest and the highest and you keep crossing those off, this is another way to go about getting your median. And if you keep doing this, it appears that you're going to be left with that same 1, or a median of 21. For brand B, here we have 1, 6, 5, 5, 1, and 1. So if we get a total of those values, that also turns out to be 19. So the middle number will be the 10th number. So if I count from the bottom, 7 is smallest number is 7, so that's the first. Then 10, 15, 15, 15, 17, and 19. So that's 7 numbers. The 8th number is 20. The 9th number is 22, which means the 10th number is going to be that middle 2, or also 22. So there the median turns out to be 22. Now, for letter C, which battery brand would you purchase and why? The medians are very close, 21 for brand A, 22 for brand B. But it looks like that, for me, this 75 hour, this 56 hour, these two numbers seem to be much, much higher than the highest battery life in hours for brand A. So if it were me, I would go with brand B because there's 2 very high values compared to the 1. Also, if you notice, battery A has 4 batteries that lasted under 10 hours, while battery B, only 1 battery lasted less than 10 hours, compared to 4 for battery A. So as long as you give a mathematically, statistically correct data value and answer, you can justify each brand. But if it were me, using the statistics, using the data, it looks like brand B is the better choice. For problem 5, the stem and leaf plot below shows the number of hot dogs eaten in a recent hot dog eating contest. Assume the stems represent the 10s and the leaves represent the 1s. So for example, this particular stem and 1 leaf refers to 11 hot dogs. So here we have to figure out which of the following statements is true, and in letter or number 1, the range is 70. Well, here, the most amount of hot dogs eaten is 81. The fewest is 11. So the range is going to be 70. So that's going to be true. Then they say the median is 46. So it looks like the biggest number is 81, the smallest is 11. The next biggest is 67. The next smallest, 27. Then I'll cross off the 64, the 29. The 56, the 35. The 52, the 37. The 52, the 39. So now I'm down to these 40s. And here it looks like I cross off the 40 and the 49 and the 42, 9. Which means I'm left with this middle 5 and 7. And the way I find the median is I just simply add those up and divide by 2. And it looks like here when I do that, or if I can just figure out what number is in between 45 and 47, it looks like the median is going to be 46. So that's also going to be true. So since both statements are true, here it looks like our answer is going to be letter C. Problem number 6, here we need to create a stem and leaf plot for the data. The data deals with the prices of 20 boxes of cookies at a particular supermarket. So I have a procedure here, some steps that we're going to kind of follow, and we're going to have our calculator help us out with this to the best of its ability. The first thing we're going to do is we're going to enter the data into our calculator and then sort the data in numerical order. We're always going to sort it in ascending order, going from smallest to largest. So take a minute, pause the video, enter the data into your calculator. To make sure you have the data entered correctly, run your 1var stat test. Here the average turns out to be a little over $2.50 a box, and here make sure that you have 20 boxes of cookies. So take a minute, pause the video, and enter your data into your calculator. Be sure then, once the information's in your calculator, to sort the data in ascending order. Now, what we're going to do is this. Let's look at the numbers in ascending order. So here are all 20 of our numbers put in order, and what we're now going to do is we're going to identify the stem for each number. And the stem is every digit except the last digit. So here we're going to need stems that go from 17, because it's every digit except the last digit, all the way up to 31. So here our stems are going to have to range from 17 to 31. Now, I know what you're thinking. Here there are decimal points. So shouldn't it be from 1.7 to 3.1? And make sure you note in your notes that decimal points are not permitted in stem and leaf diagrams. The reason why you want to create a stem and leaf diagram is to make the data easier to read, and by having decimal points in your diagrams, it kind of just clutters things up. So here our stems are going to have to go from 17 to 31. Now, I notice though, and you should notice, that some of the stems are not present. For example, I have $1.75, $1.75, so those are the stems of 17. Then I need an 18, a 19, 20, because this $2 is going to be 20. But then there's a big jump from 21 to 26. There's no values. There's no boxes of cookies in our data set that run from 21 to 26. So let me show you how we're going to note this on our stem and leaf diagram. So notice here's my stem and leaf diagram, and since we have a gap between 21 and 26, I write the stems 17 through 20, and then you use this little squiggly line which kind of denotes a break in the graph. Sometimes you'll even see the squiggly line kind of appear on the line that separates the stems from the leaves. So that's going to tell the reader that, okay, we have stems going from 17 to 20, but then there's a stop, and then they continue from 27 to 31. One of the things you want to note about the steps which I gave you here is that for stem and leaf diagrams, you're supposed to include values, stems, which are not present. So for example, if there would have been cookies going from $1.75 and then no $1.80 cookies, and then the $1.90 cookies pick up, if you're just skipping one stem, then you want to include 17, the missing 18, then 19. If there is more than one value that's missing, then we want to use this squiggly line technique to which I referred to here. Now, what we're going to do is we're going to identify the leaves for each stem. So we're going to go through each of these stems now, identify the leaves, and we're going to put the leaves in numerical order from smallest to largest. And the key is going to be if a number is repeated, you have to write down that leaf, how many times it repeats. So for example, here for the stem of 17, we have two $1.75 boxes of cookies. So next to 17 for our leaves, I'm going to have two number 5s. Here, $1.80 $1.80, I need to have a 0 to denote $1.80. For the 19 stems, I have two $1.95 cookies, so I need 2 5s. And then I have 3 $1.99 cookies, so I need 3 9s. You're always going to put your leaves in ascending order. Here I have a box of cookies that's $2, so I'll have a stem of 0 for 20. Then I have my break in the graph. Then I have $2.74, $2.89. It looks like for the stem of 29, I'm going to have a lot of leaves. It looks like I have 3 5s, because there's 3 $2.95 boxes, and 2 9s. I have 2 boxes of cookies, which are 309, so I need 2 9s. And then I have a 315, a 5, and a 9 for the stem of 31. The last step, which is probably the most important step, you have to finish by adding a key to make sure that the reader understands what the stem and leaf diagram means. What you're going to do is you're going to write either the first or last number in your data set for the key. So let me give you an example. Here, the first data value, the lowest data value, was $1.75. So one way I could denote the key, I'll actually write the word key, is you'll write 1 7, then a vertical line, and then the leaf of 5. You write equals, and now you tell the reader that means $1.75. To write your key, you must use either the smallest or largest data value. So I could have written the key that way, or the largest data value is $3.19. I could have written 31, then a vertical line, and then 9, and then tell the reader that means $3.19. So there's our stem and leaf diagram for these boxes of cookies.